Objective A. Identify and classify polynomials. Number 1. 6a squared plus 3x minus 7x to the fourth. In order to indicate whether or not this is a polynomial, we need to check two things. First thing, all the exponents that you see on the top right should be integers. Second, we do not have variables that appear in the denominator. By looking at the first one, we have three terms, 6a squared, 3x, and negative 7x to the fourth. 6a squared, this 2 is definitely an integer. Next one, 3x. Even though we don't have a exponent, but there is an invisible one right here, which indicates that this also has an integer exponent. The last term, negative 7x to the fourth, we definitely have an integer exponent. Therefore, the first one, it is a polynomial. Number 3, y plus 3y squared plus square root of y. Very similar to number 1, the first term has an invisible one, so it is integer exponent. The second term, 3y squared, also has an integer exponent. The only problem is the last term, square root of y. Square root of y, later on you will know that if you rewrite this using exponents, it's going to be y raised to the power of half. And in that case, we have a fraction in exponent. Therefore, expression 3 is not a polynomial. Classify each polynomial as monomial, binomial, or trinomial according to the number of terms. If you remember, the number of terms are determined by the number of products in your expression. In other words, multiplication. And they are usually separated by plus minus signs. So, for number 5, let's check how many products we have. 2, by itself, you could simply treat it as 2 times 1. And that is one product. Next one, negative 3x squared. So this one is negative 3 times x squared. And because of that product, we have another term right here. Therefore, this one, we have two terms. If it's two terms, we say binomial. Number 7, same idea. Let's break down every single component, see if you could rewrite them as products. Ax, you could write as a times x. 7, you could write as 7 times 1. X squared, you write as x times x. And apparently we have 3 products, so we will call this one trinomial. Next one, rearrange each polynomial in descending order and identify the degrees. Descending orders, all you need to look at are the exponents attached to the variable. We only have one variable x, so we check out the highest exponents that are attached. Apparently, it's the second term. Therefore, I'm going to write that first. Negative 3x to the third. The next one will be the third term, plus 2x squared, followed by the first term, which is plus 2x. If you want, you could put the exponents here. It has an exponent of 1. And the last term has to be the constant term, negative 8. For the constant term, the degree is a 0 degree because you could rewrite this as negative 8 times x to the 0. Remember, x to the 0 is simplified to 1. Next page. Number 11. Follow the same idea, identify the highest exponents that you see in this expression. It will be the very last term. So that will be the first one, negative x to the fifth. And then we don't have a term that has a 4th degree, therefore we skip to the next one, which is the 4th term here, plus 3x to the third. Followed by the third term, negative 6x squared, and then negative 14x, and then we have that constant term plus 36. Objective B. simplify a polynomial. We will combine like terms and then write the polynomial in descending order of powers. As a beginner, you might want to circle or highlight like terms in longer expressions based on the variable and the power. In number 13, we only have one variable, so all you need to look at would just be the exponents attached to the variable x. I will start with the highest degree. In this expression, the highest degree is 4, and there is only one term that has the 4th degree, so I'm going to rewrite that as negative x to the 4th at the beginning. Next degree is the 3rd degree. Again, we only have one term that has 3rd degree. And then I'm going to look for the 2nd degree. In this case, we do have multiple terms that have 2nd degree. The 2nd term right here, the 4th term right here, and also the 6th term right here. Also notice that if there is a negative sign in front, I also highlight that because that is part of the term. Let's combine them. When you combine like terms, you simply add the coefficients in front of the variable. The first term that I highlighted over here has a coefficient of -1. The second term, +1. And the last one that I highlighted has a +2. If I add these three coefficients, it's going to give me +2, followed by the variable part that's shared by all three of them, x squared. Alright, we're done with the 4th degree, the 3rd degree, and also the 2nd degree. Moving on to the 1st degree. There's only one term that has a 1st degree, which is the first term, so simply plus x. And then finally we have a constant term, so copy that, -1. Number 15. Again, we only have one variable here, so we only need to pay attention to the variable and the exponent. The highest degree in this expression is the 2nd degree, 4a². And then we look for the 1st degree. We have multiple 1st degrees. It's probably a good idea to highlight them, including the sign in front of it. Alright, let's combine these three. 3 plus 2, that's 5. 5 plus 5 minus 7, that's -2, followed by the 1st degree variable a. And then we have two constant terms, -5 and +9. Let's combine these two. We obtain +4. Objective C. Evaluate a polynomial. In this case, what we're going to do is we're going to substitute the value for the variable into the original polynomial and follow the order of operation to find out the final value. Number 17. The way I recommend is before you plug it in, construct the skeleton form. You might have heard this. If not, it's simply just a placeholder for your variables. Let me show you how to do this. Copy the original expression, but when you see a variable, instead of write the variable, you're going to write grouping symbols. So for example, the first one, 3z², I didn't write the z. I replaced z with a pair of parentheses. That functions as a placeholder for whatever the value that you need to insert. And then let's do the same thing for the next term, -4, grouping symbol, +9. And now we are ready to insert the value. The value here is -1, so we simply insert -1 into the grouping symbol. The benefits of doing this instead of writing it out is because sometimes you will have negative numbers that you have to insert, and people tend to make mistakes when they insert negative numbers. But if you do this way, you will have all the negative signs that you need and you will not forget about any of them. That's why I highly recommend give this method a try. Try the skeleton method. Now let's follow the order of operations to calculate. PEMDAS. We do have parentheses, but there's just a number inside parentheses, so we're going to do exponent next. There is -1². If you do that, you're going to get +1. And then we have multiplication. 3 times 1, that is 3. The second part, you have -4 times -1, that is +4. And finally, you have a constant term, +9. So this is the expression after we follow PEMDAS. Keep calculating. We have 3 plus 4 plus 9. That is simply 16. Number 19. Same thing, we're going to create the skeleton form first. I might need to leave a little bit more room for my parentheses. Plus 2.1 parentheses minus 3.2. Alright, let's insert our value. 3.14. 3.14. This expression has a lot of decimals, so it might be easier if you use a calculator to calculate. If you use a calculator to calculate, I believe you will get 50.28396 plus 6.594 minus 3.2, which gives you 53.67796. Objective D. Solve applied problems involving polynomials. 21. The owner of a factory estimates that her profit in dollars is this expression, where X represents the number of items that the factory produces. Describe this polynomial in terms of its variables and its degree. So let's check out the variable in this expression. We only have one variable, X, in this expression. In terms of the degree of the polynomial, it's determined by the highest degree. The highest degree we see is the first term, which is x to the fourth. Therefore, this is a fourth degree polynomial in variable x. Alright, thank you for watching.